Wait. No. All right. So the examples we're going to use that is more relevant to finance, it's mostly personal finance, I would say. So the first example is the Scheme 6000. Now, if you are not from Hong Kong, then you wouldn't know what this is. But if you are from Hong Kong, then you know. Several years ago, in 2011 and 2012 budget, the government, the Hong Kong government, actually gave every citizen of Hong Kong $6,000 in cash payment, right? So it's a one-time stimulus measure. It was never repeated, unlike in Macau. So it's for 6,000 cash transfer for every permanent resident of Hong Kong, even if you are not living in Hong Kong right now. Back then, even if you're not living in Hong Kong back then. So overseas residents were eligible. So now an interesting aspect of the scheme is that there's choice of receiving an additional $200 by delaying the application for 6 months. Why was there such a choice? Now the government's explanation was that this spreads out the application process, so that you won't have everyone. Like, every permanent resident is eligible. So you're talking about a lot of payment. So the government explained that it would be better to spread the payment over a longer period of time. So that's why there's this additional amount for delay. Now, just by very simple calculation, $200 for waiting 6 months over a $6,000 principal, right? $6,000 principal, that's 3% interest, right? That's 3.33% interest for waiting 6 months. So compound it to a year, that's almost 7% interest. 7% interest, risk-free, right? Unless, you die during that 6 months. Otherwise, it's pretty much risk-free. So if you consider any form of investment, 7% risk-free is like just an opportunity that no one should pass on, right? Especially when you consider so many people would put their money into certified deposit that pays like less than 1% interest, right? One of the students several years ago, he ran a questionnaire for his STOT paper. So that's a senior thesis paper. He asked 59 of his classmates is not incentivized. Well, usually student research wouldn't be incentivized. It's going to be hard to incentivize in this case anyway. So the questions are very simple. There are 3 questions essentially. He asked how much bonus is needed for delaying the receipt of $6,000 for 6 months, for 12 months and 24 months respectively. How much money his classmates wanted in order to wait. Now this is a valid question because the payment was made to anyone 18 and older, so that includes most university students. So with the questionnaire received, right, you can estimate a beta and a delta, because what you can do is you can have essentially 6,000 today versus beta, delta, and the delta is for 6 months, some additional amount. I would call that what should I use? Something like, say, X 6 months. Then you have 6,000 equals to beta delta square X 12 month and so on, right? So you can estimate both beta and delta by having multiple values, right? Okay, so with these numbers, what did he find? So first, beta on average is 0.934. There is distribution, which is bell-shaped, although it's not completely symmetric, suggesting that most people were present biased. Most people were present biased. Asking them to wait by itself entails a significant interest. At any additional period carries a relatively low interest. So the beta, as you see, one would be, so one, this column, one would be time consistent. So just continue constant discounting. So this is the highest bar, but in terms of cumulative distribution, then you can see that most people, for sure, are present bias. Tiny proportion of people were actually future bias. They are actually patient, but it's a very small number, right? So this is okay. Delta 0.877, very close to 1, which is pretty much what you would expect. The numbers are very close together, ranging from 0.97 to 1. No one is bigger than 1, so it's all right. Very close to what you would expect. So this is a nice demonstration that what would affect actual policy. So after the money was distributed, the government actually announced, I think they actually announced how many people waited, or maybe how much money they set aside for the extra interest, $200. And the answer is very few people wait. Very few people wait. I think out of the, so we have so $6,000 per person, right? And you multiply that by like the several million residents in Hong Kong, right? So you're talking about billions of dollars, right? I think they reserve only something like 300 million for the extra interest. That definitely less than 1/10. I think it's at most 1/10 of. So most people chose not to wait, right? And given how high the effective interest rate is for risk-free investment, this suggests that people are truly present bias. Unless you don't trust the government, which I think it's not very reasonable assumption in Hong Kong. The Hong Kong government is so rich, there's no way that it's going to go bankrupt in 6 months, right? If you are familiar with Hong Kong government's finance, then you know every year they predict a deficit, and then every year they run a huge surplus. It's already up to a point where if you have rational expectation, you wouldn't trust the government's estimate. I don't even know why they are actually making the estimates, because I don't think anyone trusts that estimate. So people are present biased and they don't want to wait. Okay, so I mentioned that. So I already mentioned all these. Essentially, these are just the calculation of actual numbers, right? So the return of the reward is lower than the estimated average discount. There's also a curious relationship between beta and delta, which they are negatively correlated. So people who are more present bias are more patient in the future. I'm not sure this is actually whether this is just an estimate, an artifact in estimation, or it truly exists. There's not much existing research on that, so there's not much I can say about this. All right. So, does commitment really help? Does commitment really help? So this is about retirement savings. This is about retirement saving. This is a study by Richard Thaler and Benanzi. You have seen Thaler's name popping up a lot. Now, Thaler is a very famous economist, very famous, particularly for behavioral economics. He's also very proactive in running the kind of high-profile studies. If you anyone watch the recent movie, The Big Short, 孤注一擲, right? Then Thaler was actually in the movie. He was playing blackjack with a female star, right? That's Thaler, like kind of a old, slightly fat guy, right? Caucasian. So this study, okay, what is this study about? This is a study on the employees at Philips Electronics. And what was the test involved? Giving subjects an option to increase their savings to their retirement account by 1 to 3% automatically each year. The increase will start once savings rate reach 10%. So in the United States, you don't have a central government mandate retirement mechanism. So each company has its own policy. And in this case, Philips Electronics in US offer the employee a plan in which they can deposit a certain amount of money from each paycheck into their retirement account. And this study gives people the option of increasing their savings automatically in the future, up to a maximum of 10% savings. So let's take a look. What do we see here? All right, now, so it's a very large study because it's run through a company. So as you see, it involved 7,000 people. 7,000 people in the control group, and the test group actually much smaller because it's not easy to convince company to employ such scheme to a whole company. So the test group usually have just a couple hundred people. But still, this is already a very significant study, right? It takes an economist like Thaler to convince a major company to conduct such a study when you're playing around with people's retirement saving. So now what's interesting is that, first look at the control group A. About half the people weren't actually saving anything, right? About half the people weren't actually saving anything. And then about half, and slightly more than half, were saving. So this tells you how bad the situation was. And it's probably still as bad as it is as then. Is that without a mandatory retirement saving mechanism, a lot of people will not save for retirement. Okay? This is just a reality. The average savings rate among those who did save was something around 5.6%, 5.6 to 7.7%. That's pretty close to what the government mandates Hong Kong workers to save, right? 5%. Okay, 5%. I believe I believe the reason why these people don't save is that Philips most likely offer a pension that is similar to MPF in Hong Kong. The Philips probably contribute a certain percent of each employee's income to their retirement account. My guess is that's probably the case. Otherwise, I don't think 50% of people won't save. But still, it's not a lot of money, even if Philips saves some for you. Just like in Hong Kong, if you just have the employee's contribution of 5%, it's not going to be a lot of money. Okay. Right. So test group. Test group is the group that gets this offer where they can choose to have their savings automatically increased by 1 to 3% at their choice. They can also opt out if they want. Right? So, or among the employees who were already saving money on their own into their retirement account, so you see there are about 180 plus 339. So that's about 519 of them, right? 519 of them. Well, among them, 180 choose to join this program. So you have slightly more than 1/3 of the test subjects who were already saving money, joining the program, right? So they once again they were saving about 5% before this study, and after the study, their saving goes up roughly. As you see, this is just this has been run just 1 year, then it went up 1%. So basically, they all choose to for the savings rate to go up automatically 1%. Now, among subjects who weren't saving already, this participation rate is very low. Only 1 in 10 participated. But the savings rate go up dramatically from nothing to 5%. Right? There's some spillover effect, it looks like, because even for those who weren't saving and not joining the program, then they still have increased their savings to 2%. But in any case, this is a very significant effect, right? If someone who wasn't saving joined this program, they're actually going to save a lot more. This is interesting because there's nothing that stops them to make this contribution to begin with. They can totally choose to contribute any amount themselves. Yet somehow they need this commitment where this rate of saving automatically goes up in order to save. So that sounds very much like a commitment. Right? I commit myself to deposit part of my paycheck in the future to my retirement account. So below is just separating. There's 2 divisions participating in the study, and it's just separating the 2. So overall, on average, then the savings rate goes up by about 1.2%, I would say. This number, 1.2%. 1.2%. Okay, so small effect, but still quite significant if you compound over many years of work. Okay. Now, here's another study. This one is not about finance, but it's very much about you. This is a study by psychologists. Procrastination, deadline, and performance, self-control by pre-commitment, published in Psychological Science, one of the top journals in psychology. All right, so it's what a professor can do in class. So this is, I believe it's an MBA class. 99 students in class were required to write 3 papers. 51 students were allowed to pick the deadlines for their own papers. How good? That's going to be amazing, right? If you can pick the deadline for your own paper. 1% late penalty for each day. Now, just before we go on, it should be quite obvious to you that the rational choice in this case is set the deadline at the very end of the semester, right? You can always submit early, right? But in case you for some reason need to submit late, setting a later deadline would allow you to avoid the penalty. 48 students were given evenly spaced deadlines. So this is instructor assigned it. One paper in the first 1/3 of the course, and then the 2/3, and then the end. All right. The first observation is self-imposed deadlines were significantly earlier than the last day of class. This already shows you people think they need commitment because there's no rational reason to do that at all. Okay? There's no reason to do that at all. Right? As you see, this is the distribution of the deadlines. Right? Remember, this is completely self-imposed. First paper, roughly, like the tallest bar is about the third week, right? Yeah. Then there's a big bunch on in fifth week. A lot of people choose the last week, so a lot of people are rational. But once again, if you look at the cumulative distribution, most deadlines are before the very last day. And then, interestingly, the second deadline mostly happens around the 8th week, right? Why? And then, even more interestingly, even for the last paper, a lot of deadlines were set like 1 to 2 weeks before the final date, right? So you would need some sort of commitment story to explain this, because clearly the rational choice is to set all deadlines at the very end. Okay. So people need commitment. Now, this is not controversial for psychologists. It's only controversial for economists. For psychologists, people obviously need commitment. Right? So this is actually not the main focus of this paper. What's interesting is that the group with evenly spaced deadlines have higher grades, suggesting that students in the first group were not setting deadlines optimally. Right, this is what's so interesting, is that actually it seems like the students' deadlines weren't actually ideal. It's like this paper argues that it's actually better for the instructors to set deadlines for you. So that's why you have assignments and midterms and final exams. Because if we don't set these, then you don't study. But that's what the paper say, right? All right. Here, so this is the same paper, but it's a separate study. Okay? It's a separate experiment. 60 students were paid to proofread artificially generated articles. So the articles doesn't actually, basically it doesn't make sense. I mean it's words that add together doesn't make much sense. Okay, it's artificially generated. But then you can still correct them for English, right? So once again, the 60 students were divided into groups. 1/3 have evenly spaced deadlines, 1/3 have self-imposed deadlines, and 1/3 have a single deadline set to the end of the experiment. Once again, there's a penalty, $1 penalty for each day, deducted from their payments from proofreading. Right? So, here are 3 measures of their performance. 1, the number of errors detected in the article, delay in submission, and how much money they earn. They earn money by finding errors, right? The black bar is the evenly spaced deadline. White bar, self-imposed deadline. Gray bar, no deadline, it's at one deadline at the very end. And so the bar is the average. The I bar is, I think the I bar is probably the confidence interval of the average. Right? So what do you see? quite clearly, right? The evenly spaced deadline perform the best, earn the most money, delay the less. And followed by the self-imposed deadline, and the end deadline was the worst. Significantly fewer errors detected, significant delay in submission, earn very little money. Right? So once again, it looks like that students need deadlines set for them. Now finally, we come back to this idea of future bias. Future bias is that when you ask people whether they are willing to wait a day for equal amount of money, sometimes they say yes. So this violates exponential discounting because with the standard economic model, you should always prefer getting money now versus getting it tomorrow. And this violation is in the opposite direction of present biasness. And in this case, people are having a future bias in the sense that they are more patient than what the exponential discounting model suggests. And there are experiments that people are future biased, right? In this particular studies, they are future biased for 22.4 days. Okay, now once again, future bias hasn't received as much attention compared to present bias. So it's an interesting aspect. How come people are future biased? Although there's not much I can say about it right now. All right, there are alternative theories to present biasness. In particular, there are alternative theories other than hyperbolic discounting and beta delta. So beta delta and hyperbolic discounting is about saying you are impatient today, right now. It's special, so you are impatient. There are alternative theories. Now, suppose your friend tells you earlier that she does not want to eat ice cream, but now when she is in front of some ice cream, she eats it. Okay? Now, one explanation is present bias in that eating ice cream is unhealthy, but this mostly affects the future while the enjoyment of eating ice cream is immediate, so she eats the ice cream despite saying she doesn't want to do so. But this might not be the most intuitive explanation. A more intuitive explanation perhaps is that she's simply tempted by the presence of ice cream and knowingly chooses to eat that ice cream. This is called temptation utility. That is, when something that is tempting is in front of you, your utility function will change to include a component that gives you very negative utility if you don't consume the item right now. Right? So this is called temptation utility. Another possibility is she might not even be thinking rationally. The presence of ice cream causes her to enter a hot state in which she acts by instinct. This is called cue theory or two-self theory. So this is like people have two self. I have a rational self which says, I need to eat healthy. And then there's another me self that's more instinctive, right? So when I see an ice cream, it just triggers my raw basic instinct that it's something that I should eat, right? Sugar triggers my brain reaction and I just eat ice cream, okay? This is called cue theory or two-self theory. Some of the models, mathematically, are not necessarily very different. But the interpretation is different. From a psychologist's point of view, two-self model is very popular. Generally speaking, it's quite accepted that human decision-making involves multiple levels of thinking. So if you read the book Think Fast and Slow by Kahneman, then he talks a lot about these kind of ideas. So In terms of economic modeling, it hasn't received too much attention. There are some papers that have models on these, but present biasness has received a lot more attention, comparatively speaking. Temptation utility is preferred by some economists because you can claim that it's not time inconsistent. Some economists really dislike the notion of time inconsistency because you're suggesting that people are not rational, so they don't like that. So the temptation utility, on the other hand, is, you can say, is time consistent. It's not about time. It's about the utility change involved when you have an item in front of you. So there are other examples and exercises that you will see in assignments later on. But as I mentioned last week, we're not going to test beta delta in the exam. So it's going to be for the final exam.